-6 kg. What is this mass in microgram? When you're performing a conversion, we have got 5 by 10 to the power -6. This is in kgs. The first thing that you want to do is remove that k from the front. And how do you do that? You are going to multiply. Since I've got a kg on top, I'm going to put a kg down. And then I'm going to put a gram on top. I'm removing the k. I'm converting the kgs first to grams. Now ask yourself, between a kg and a gram, which one is bigger? A kg is bigger. So put a 1 in front of a kg. And k means 1,000. So 10 to the power 3. So what you see is that this kg will cancel with this kg. We have converted to grams. The next thing, now convert the grams to micrograms. So again, multiply. You have got a gram on top. I'm going to put a gram down. I want to go to microgram. Between a gram and a gram is bigger. So I'm going to put a 1 in front of a gram. Always put a 1 in front of the bigger unit. Micro means 10 to the power 6. Okay. It actually means 10 to the power -6. But every time you put a 1 in front of the bigger unit, forget about the negative power. So this gram will cancel with this gram. So you know from the rules of indices, when you are multiplying numbers of the same base, add the powers. So 10 to the power -6, 10 to the power +6. If you add the powers there, -6 plus 6, that will give you a 0. A 0. And you know 10 to the power 0, the answer is 1. So you've just remained with 5 times 10 to the power 3. So that gives us the answer being this one. Please, if you are not okay, be free to ask. Number B. A motorist travels 320 kilometers at 80 kilometers per hour and then 320 kilometers at 100 kilometers per hour. What is the average speed of the motorist for the entire trip? So you can see what is happening. First, travels 320 kilometers at and 80 kilometers per hour. That is the speed there. And then 320 kilometers at 100 kilometers per hour. What is the average speed? Remember, we want the average. And how can you find the average? We've already been given the speeds here. So the first thing is, I want to find the time in which this is happening. Okay. So if you see the first distance, we can just put first distance d1 that was covered is 320. That's 320 kilometers. This distance was traveled at this speed. So we can call that as our v1, which is 80 kilometers per hour. The second distance is 320. So that is going to be d2, 320 kilometers. And that was traveled in a speed v2 of 100 kilometers per hour. So what is the average speed of the motorist for the entire trip? And how can we find average speed? You know that speed is distance over time. So v is going to be distance over time. So we first need to find the total time that was taken in this journey. So therefore, let's find t1, the time taken to cover the time taken here. That is going to be our t1. Using the same equation here, v is equal to d over t. We can just rearrange it, and that will give us time being equal to distance over velocity. And so the distance covered in the first period, that is a 320, and then the velocity, that is 80. So the 320 over 80, that is going to give us 4. Remember, this is going to be in hours. This is t1. And then to find t2, we'll do the same. Divide the distance, which is in this case 320, over the time. Now for the second period, the velocity is 100. and this is going to give us 3.2 hours. So we need to find the average time that was used, or the average time that it took to be able to travel. So the average time is going to be a sum of these two guys, 4, or the total time, not average. Remember, average means you add then you divide. So total time. Add 4 plus 3.2. So I've even used the capital T there. That is going to give us 7.2 hours. So this is the total time. And then therefore, for us to find the average distance, how do you do? Sorry, we are calculating average speed from the question. Now, speed, as we said, is given by the average speed will be given by the total distance over the total time. Okay, so therefore, v is going to be the total distance. We have got d1 plus d2, 320 plus 320, that is a 640, over the total time, that is 7.2. And this is going to give us 88.9. This is in kilometers per hour, and 88.89 is the same as 89. So that gives us that. C is saying a 30 Newton force acts on a body moving with an initial momentum of 10 kg meter per second. Find the body's final momentum after 3 seconds. Okay, so we've been given the mass, the force that is acting on a body which has got this momentum. Now we are going to use what we call the impulse momentum theory. What does it tell us? Impulse momentum theory tells us that impulse is equal to change in momentum. How do you find impulse? Impulse is given by force multiplied by change in time. And then change in momentum is given by final momentum minus initial momentum. The question is saying initial momentum is that find the body's final momentum. So final momentum minus initial momentum is what gives us the change. So force here is 30, and this happened in a time period of 3 seconds. That's the change in time. The final momentum is what we want, minus the initial momentum. Initial momentum is a 10. 30 times 3, that is going to be a 90. I'm going to get this 10, take it the other side of the equation, so it becomes positive 10, and that will be equal to final momentum. Therefore, final momentum is going to be 100 kg meter per second, which is that one there. Is there anyone that is left out? Well, okay. Okay. So, next question. A dolphin leaps out of the water at an angle of 35 degrees above the horizontal. Find its vertical component of the velocity if its horizontal component is 7.7. Okay. So let's say this is the water. That's the water body. And then you have got a dolphin that is ripping out. There is a fish. There is a fish. So this fish is going to jump out of the water. You can see if it jumps out of the water, the angle that it is making is 35. And we've already been given one component of the velocity. So we're going to have this component of the velocity. This is going to be the x component of the velocity. And that's what we've already been given, Vx. The question is saying find the y component of the velocity, that is Vy, at which the dolphin is going to move out of the water. So we don't have the actual velocity. We only have the x component, and we have the angle. Now you know that tan theta is given by y component over x component. This is actually y component of the velocity over x component of the velocity. This is going to be tan. If the angle is 35, that will be equal to y component of the velocity divided by the x component of the velocity, which is 7.7. Therefore, this tells us that Vy is going to be equal to 7.2 multiplied by tan 35. And when you punch that on the calculator, you get 5.4 meters per second. So that gives us the answer. And then E is saying the magnitude of the resultant of two forces is at maximum when the angle between them is the resultant of the maximum of two forces. Let's say this is a box. You are applying a force here. Okay. Now there's a second force that you're applying. If you want the resultant to be maximum, remember resultant force or the net force is given by the sum of forces F1 plus F2. So the only way F1 and F2 produce maximum resultant is if they are going in the same direction. Because if I apply any another force at an angle, it is going to be reducing the total force, because for me to find the average I'm going to be using the Pythagoras theorem. And worse, if I even apply the second force on the 180 degrees, it means that they will actually cancel out. So for me to have maximum resultant force, the angle between the two forces should be zero, meaning they are going in the same direction, because their sum will just be an addition. But at any other angle, the resultant is not going to be that big. It will be reducing. By the time you reach 180 degrees, they will even be canceling each other. If we're saying a force that produces an acceleration of 1 meter per second squared on a mass of 1 kg is referred to as, do you get what he's saying? A force that produces an acceleration of 1 meter per second squared on a mass of 1 kg is known as. So if you look at force that produces an acceleration on a mass, so that is meaning mass times acceleration, and this is producing an acceleration of 1 meter per second squared on a mass of 1 kg. So in other words, if you what force is equal to 1 kg meter per second squared. 1 kg meter per second squared, that force we call it a Newton. Okay, it's a Newton. 1 Newton is 1 kg meter per second squared. What is a collision code when colliding bodies are deformed? Say this is a vehicle that was going in this direction. It hits another vehicle that was moving in the opposite direction and they deform. So collision that produces deformation is inelastic collision. Inelastic collision. You also have a perfect inelastic collision, where collision, the objects that hit each other sticks and then they end up moving together after collision. Elastic collision, there is no sticking, there is no distraction. Let's say for example you hit one ball and then it hits another ball and then they end up moving like that. Number H, find the momentum of a body of mass of 4 kg with kinetic energy of 32. Now for this one, I can use different formulas to calculate the same answer. One thing we need to know is that there's a relationship between kinetic energy and momentum. There's a relationship. Now you know that how do you find momentum? Momentum P is given by change in, it's actually mass times change in velocity. That's how we calculate momentum. But how do you calculate kinetic energy? Kinetic energy is given by half mv squared. That v, we can say it is a change in velocity squared is actually change. So you see from here I can make change in velocity substitute the formula. So I'll say change in velocity is going to be equal to momentum over mass. And then this can give us kinetic energy being equal to half mass. Where there is velocity squared, we'll put momentum over mass, and this will be squared. This will give us kinetic energy being equal to half mass momentum squared over mass squared. You see, one m will cancel with one m. That gives that kinetic energy is equal to, on top we have got momentum squared, down we have got 2, and we have got m. So this is the equation that relates kinetic energy to momentum. Now that we know the equation, we can make a substitution. And we are simply going to say kinetic energy have already been given as 32. And that will be equal to momentum. Find the momentum, that's the equation. Momentum squared over 2 times mass. Mass is 4 kg. So momentum squared is going to be equal to, or multiply 2 times 4, then times 32. I want to remain with momentum, so square root both sides. Momentum is going to be equal to 16. The unit for momentum is kg meter per second. But of what has been given here, we don't just have 16 kg meter per second. We have been given gram. So, in a kg, you have got 1000 grams. So, meaning that 16 kg meter per second is the same as 16. Where there is k, we'll put 1000. 1000 is 10 to the power 3 gram meter per second. Okay. So, this would be the answer, which is C. In case you didn't know, okay, but I don't know the direct equation that relates velocity, that relates momentum and kinetic energy. Then how do I calculate the momentum since I don't know the direct relation? The goodness with science is there is more than one way to kill the rat. So in such a way, what we are going to do is, since we've been given, that momentum is mass times change in velocity, but we don't know the velocity, but we know the kinetic energy, would have just said that kinetic energy is equal to half mv squared. Kinetic energy is 32. That will be equal to half. The mass is 4. We don't know the velocity, so v squared. I'll divide, so this will be 32 is equal to half times 4. That is a 2v squared. Divide both sides by 2. So 2 into 32, that will be 16, meaning that velocity is going to be 4 if you square it both sides, meters per second. And then you now say momentum is mass times velocity, or change in velocity. The mass is 4. The velocity is, we've calculated 4. This will give us still 16 kg meter per second. But again, convert the kg to gram, so it will still give you the same. I is saying, what is the unit for power? What is the unit for power? Now, power is given by work over time. And work, we know there are different ways. Work is given by mass. Actually, work is force times distance. Okay? Because we define power as the rate of doing work. That will be over time. So force is given also. How do you find force? Force is given by mass times acceleration, and then times distance over time. So the mass is in kg, acceleration is in meters per second squared, distance is in meters. In the denominator we've got time, time is in seconds. So this gives you kg, this meter times this meter gives us meters squared. Okay. This second, it is a per second. Per means that it is in the denominator. So it is multiplying with this. So next question, J. For a body thrown upwards, the time it takes to rise is the same as the time it takes t to fall because, so this is supposed to be 2 4. So for a body thrown upwards, the time it takes to rise is the same as the time it takes to fall because its mass changes as it goes up and falls. The body experiences the same value of air resistance in both directions. Rate at which it decelerates upwards is the same rate it accelerates downwards. Rate at which deceleration downwards is the same as rate it accelerates upwards. Now, when a ball is going upwards, when you throw a ball, initially it has got a velocity, but by the time it reaches the maximum point, the final velocity is going to be zero. So meaning that as it goes up, it decelerates. So rate, it decelerates upwards. And when a ball is now coming from top, it is starting with a velocity of zero, but it is going to hit the ground with a maximum velocity. So the going downwards, it is accelerating. Going upwards, it is decelerating. And the rate of deceleration upwards is the rate same as the rate of acceleration downwards. Does that make sense? Are we okay? All right. So we can now go on to the other section. I want to you to see that you have got different units for power. Power is given, I said that power is given by what? Wake over time, isn't it? And wake is given by force times distance over time. So I want to just make sure that this is correct. Force is given by in newtons. Distance is given in meters over. In the geometry I've got time. Time is given in seconds. So actually the unit for power here is Newton meter second. Okay, Newton meter second, which is the same as the other one I gave you, kg meter squared per second to the power 3, not the watt second. Watt second is going to be the unit for wake. Remember, power is equal to wake over time. So wake is going to be power times time. Power is given in this Newton meter second is the same as a watt. So that will be watt, time is in second. So watt second. Watt second is the unit for wake, not power. Please, let's correct that. Section B, question 2a. The x component of a vector is negative 25 and the y component is positive 40. What is the magnitude of A and what is the angle between the direction of A and the positive x-axis? Okay, so can do this. So we can start. What have we been given from our question? We've been told the x component. So meaning v of x, the x component of A is negative 25. And then the y component Vy is positive 40. What is the magnitude? Now, how do you find the magnitude of a force? Magnitude of a force, of a vector V, simply given by the square root of the x component plus the y component, and each one of these is squared. So this is going to be negative 25 squared plus 40 squared, and then square root that. So this is going to be, if you punch this on your calculator, to give you 47.17 meters. Second part of the question is saying what is the angle between the direction of A and the positive x-axis. So if you look at this vector, x component is negative 25. Let's say negative 25 is here. Y component is positive 40. Let's say positive 40 is there. So this is where the vector is. The question is, what is the direction between, what is the angle between the direction of A and the positive x-axis? So you want this. So how can you find the angle? The first thing is for us to find this angle here. So we'll say theta is given by tan inverse of y component over x component. And that will be tan inverse. The y component is 40. X component is negative 25. So simply punch that on the calculator. It gives us 58 degrees. So this is the angle here. It's 58 degrees. Okay. And then it's actually negative 58. If you punch on it, it will give you a negative. Negative, just every time angles are measured going in this direction, they're always negative. That's why this angle found it as negative 58. But now, because this is a straight line, this is a straight line. If we know one portion and then we want to find the remaining angle, we'll simply remove from 180. So say 180 minus 58, which is the same because it's already negative. So we'll just say negative 58 plus 180, and that gives us 122 degrees. A student carrying a 5 kg bag puts it on a balance seat hanging in an elevator that accelerates upwards. What is the apparent weight of the bag? Now this is something here. It is in an elevator. This elevator is accelerating upwards. Newton's second law of motion tells us that the net force is given by mass times acceleration. Net force is given by the force that is pulling you in the direction of motion. The acceleration is going upwards. So I've got a force that is pushing you upwards. Okay. And then minus a force that is going in the opposite direction. Everything has got a weight force. Weight is going downwards. So minus a weight. Net force is given by mass times acceleration. Now the force that is present in the elevator, you call that as a tension. Minus weight is given by mass times gravity. So I'll take mg the other side. So you are going to find tension to be equal to ma plus mg. We can even factorize out the mass. We've been told the mass, this bag has got a mass of 5 kg. And that to be equal to acceleration. It is accelerating upwards at a velocity of 1.75, at an acceleration of 1.75, plus the gravity. Gravity is 9.8. So if you punch this on your calculator, you are going to find that is the weight, the apparent weight is going to be 57.8 newtons. This tells you that when something is accelerating upwards, it appears to weigh much heavier than the